Okay, this is a quick lesson on exponential growth and decay. For those of you who may have missed class on Thursday. So the formula that you always want to use is y equals ae to the kt. A is your starting amount, y is your ending amount, k is your rate, and t is your time. Now your rate will be negative if it's decay and positive if growth. Growth would be population growth, bacteria growth. Decay would be something like this example, coffee, or zombie apocalypse, something like that. Okay, so let's start this problem. You have 130 milligrams of caffeine. You're eliminated at 11% per hour. How long will it take for half of this caffeine to be eliminated? So your starting amount is 130. So you have 130 to start. And E is just the same E that's in the natural log. Your rate is negative 0.11. And you're looking for T. So it's negative because you're losing caffeine from your system, so it's decay. And it's 11%, so you would need to put it in decimal. And we want to know how long it takes for half of it to be gone. So half of 130 would be 65. And now we just need to solve for T. So what we're going to do is isolate the exponential, so divide by 130. So this would be a half. And this is also called half-life because it doesn't matter how much I start with. When I cut it in half, I'm always going to end up with a half here. So if I start with 200 milligrams of caffeine, this would be 100, and then that would also give me a half. So you'll see that in the book. Occasionally you'll see something called half-life, and that's what they mean by that. So now we're going to put it in log form. So one way to do that is to do log base E of 1/2 equals negative 0.11 t. And we know that log base E is natural log, so we could actually always jump right to this step if we wanted to. And then we just will evaluate this in the calculator and then divide by negative 0.11. And we're going to end up with t equals 6.3 hours. So I would recommend maybe working through this problem again, and then if you get stuck, you can look back at the work here. So that's if we're given the growth rate. I want to do a problem where you're not given the growth rate, which should be an example similar to something like this problem, which we'll also do in class, but if you're not in class, then this is a good example. So the average cell phone price was $3,395 in 1984. And in 2002, the average price was $145. So we're not given K here, but we're given a starting amount, an ending amount, and we're given a length of time. If you were to subtract 2002 from 1984, that would give you 18 years. So that would be your time. So it's asking for an exponential function. You need k in order to find an exponential function. So what we're going to do is we're going to solve for k. So we would start with 3,395 e to the 18k, and again 18 comes from 2002 minus 1984. And that is equal to 145. This is very similar to the other problem. K is in the same place as T. So we're going to go through the same process. We're going to divide by 3,395 on both sides. Okay? And so then we will natural log both sides. And then we will have 18k over here. and then you're just going to evaluate this in the calculator and then divide by 18. I don't have a calculator. So let me get one. Sorry for the delay. Alright, natural log of 145 divided by 3395. And then you're going to divide by 18. You should get negative 0.175. So I would follow along and do that. Negative 0.175. It's always a good idea to round to 3 decimal places here, because you don't want to lose accuracy. 3 decimal places. Okay, so once you get that, then what you want to do is, remember, this is just k. So now you want, it says to write an exponential function. So the general function would be y equals 3395, because it's your starting point, e to the negative 0.175 t. So you leave y and t in general. You don't put anything in for those. And notice how the 0.175 is negative because this is decay because the price is decreasing. Okay, part B says, estimate the price of a cell phone in 2015. So, in 2015, that would be 2015 minus 1984 is 31. So we're going to use t equals 31. So we do 3395 e to the negative 0.175 times 31. Now be careful when you put this in the calculator. You want to make sure that you get this whole exponent, e to the whole exponent. So this is going to give us, if we do this in the calculator, e to the negative 0.175, you should get around $15. Again, if you round this a little differently, you're going to be close to 15, but you might not be at 15. So as long as you're plus or minus $1, you're okay. Is this realistic? Probably for the type of phone that they had in 1984. Remember, they didn't have smartphones back then, so for just making phone calls, I would say that's probably pretty accurate for a flip phone or something like that. Okay, lastly it says, part C, at this rate, what year will the price be $20? So now we're actually solving for y. So we're going to set we're solving for t. 20 equals 3395 e to the negative 0.175 times t. So we want to know how many years it takes for the price to go from $33.95 down to $20. Again, same process. Divide by 3395. And then you're going to natural log both sides. You're always using natural log because of e. That's important here. And then you would divide by negative 0.175. And so you would get around 29 years, which is going to put you somewhere around, let's see here, 1984 plus 29, around 2013 or so. So this is basically the 4 types of questions you could see. Part A, we had to find K first. This is what it's going to be like on your quarter exam. Find K, find the equation, and then evaluate it for a certain year. That's part 3. And then part 4 would be find the year that it gets to a certain amount. So if you can do those 4 parts, then you're in good shape. So I would redo this problem on your own and go back through and make sure that you can get these answers. And again, we can do this next class or in the mornings if you still need help.